Hello and welcome to 4-3 Right Triangle Trigonometry, Day 3. This is going to wrap up the section, and it's a lot of applied type problems. So it says here many applications of trig involve solving right triangles. In this type of application, you're usually given one side of a right triangle and one of the acute angles and asked to find one or the other sides, or you're given two sides and asked to find one of the acute angles. In example 8, we're given an angle of elevation, which represents the angle from the horizontal upward to the object. In other applications, you may be given an angle of depression, which represents the angle from horizontal downward to an object. Like if you're in an airplane or a hot air balloon and you're looking down to something, that would be an angle of depression. Now it says here to solve a right triangle. That means you're going to find all the missing stuff. Like here, I've got the first variety. We've got a right angle, and one of the acutes, our acute is 40. We've got one side, that's this adjacent side, is 10, and we want to find all the other stuff. So let me label this missing side here A. It's across from angle A. Side C, the hypotenuse is across from angle C. So we want to find all missing pieces, and the first thing to find for us will be angle B. There are 180 degrees to go around. There's 90 degrees in this right angle, and that leaves 90 degrees between the acutes. So if this angle is 40, 90 minus 40 is 50. Angle B is 50 degrees. Now we want to find all the missing sides. I'm going to go from angle 40's perspective. That was our first given angle. And this comes down to what side do you have and what side do you want. In this case, let's go for angle A first, or side A, excuse me. Side A is opposite, and the side that we were given is adjacent. So we got to ask ourselves, what trig function deals with opposites and adjacents? Well, that's tan. The tan of our angle, 40, is equal to the opposite side A over the adjacent side 10. Now, before we start punching this in our calculator, let's get this all on, or the A by itself. So here's A. To get rid of this divide by 10, we're going to multiply both sides by 10. So that's going to be 10 times the tan of 40. Do not multiply the 40 by 10 and make it the tan of 400. Trig functions do not work that way, so you'll get the wrong answer. So we punch this in our calculator, 40 degrees, hit the tan button, multiply that answer by 10. A is approximately 8.391. 8.391. I didn't put any units in there, but it'd be feet or miles or meters, whatever units were given to set up our triangle. So side A, 8.391. Now, missing a side hypotenuse here, C, we could do the Pythagorean theorem and solve for that, but we're practicing our trig function, so let's set one of these up with a trig function. Again, let's go from angle 40. From angle 40, we have the adjacent side, and we want the hypotenuse. So what trig function deals with adjacents and hypotenuse? Well, that's the cos. The cos of our angle is equal to the adjacent side, 10, over the hypotenuse C. Now, the first time you see one of these, we're going to do a couple steps of algebra to get the C by itself, but that'll lead us to a sort of a shortcut. So let's see here. First step, we're going to multiply both sides by C. So that's going to be C times the cos of 40 is equal to 10. And then to get the C by itself, we're going to divide by cos 40. So C is equal to 10 over cos 40. So when you run into one of these and you're setting it up on your paper, and you have the denominator is the unknown, here our C is below the 10, and we want to get the C by itself, so in two algebraic steps, we basically just switched these locations. So the C jumped up here and took the place of cos 40. Cos 40 jumped down under the 10 and took the place of C. And now it's ready to be punched in on the calculator. So I'd hit 10, divide by, 40, hit the cos key. When you hit the cos, it will take the cos of 40, so you got to hit the equals to actually do the division. So 10 divide by 40 cos, and then equals. C is approximately 13.054 units. And our triangle has been solved. All missing sides found, all missing angles accounted for. Okay, so here's an applied problem. We're at the Washington Monument. We are standing 115 feet from the base, and if we look up and measure the angle of elevation to the top of the monument, it is 74.3 or 78.3 degrees. Now, a lot of times when the book gives you a picture, it's cluttered up. There's a tree in there, and the clouds are distracting me. I'm going to draw my own fairly terrible triangle here. Here's my right angle. They've labeled this side y for the height. Let's stick with y. This side is 115. And they gave us the angle of elevation to look up at the top of the monument here is 78.3. So let me get the distracting picture out of the way. And let's figure out the side we have and the side we want. The side we want is opposite. The side we have is adjacent. So what trig function deals with opposites and adjacents? Well, that's tan. The tan of 78.3 is equal to opposite y over adjacent 115. Now again, if the y was in the denominator, we would just switch those places. But here's the nicer variety. Y is in the numerator, so we're going to multiply both sides by 115. 115 times the tan of 78.3 degrees. Punch it on your calculator, 78.3, hit the tan key, multiply that by 115. Y, the height of the Washington Monument, is approximately 555.31 feet. And we found that just knowing the angle of elevation and how far we were from the base of the monument. Excellent. Now, they said one of the other varieties of triangles to solve is when they give you no angles except the right angle. So here's one of those. It's going to take a different button on the calculator, but it's nothing too bad. We've got a lighthouse right here. It is 200 yards from the bike path. That is a right angle from the bike path along the edge of a lake. A walkway to the lighthouse is 400 yards long. Find the acute angle theta between the bike path and a walkway. So I'm just sort of going to trace over this triangle. Here's that side. Here's the trail. Here's the bike path. This is our right angle. This side is 200, and the hypotenuse is 400. And I'm going to put my angle up here in black ink, theta. Okay, we want to find theta. So from theta's perspective, well, actually, before we dive into that, let's do a little Pythagorean theorem. Oh, no, I guess in this one, they didn't ask us to solve the triangle. They only want that angle. I was going to find the missing side, but, that would just, well, it wouldn't be a waste of time. It would be fun, but they're not asking us to do it. We'll do that later. So from angle theta's perspective, we have an opposite side. We also have the hypotenuse. So what trig function deals with opposite and hypotenuse? That would be sine. The sine of angle theta is equal to the opposite side, 200, over hypotenuse, 400, so that if we reduce it down, the sine of theta, we don't even have to reduce it down. If we punch that in our calculator, 200 divided by 400, and we hit, that's right, I got to the sine inverse. Let me do this. We want to get theta by itself we got to detach it from sine without blowing up the angle. Trig functions have inverses, so if we do on this side the sine inverse, just like squares and square roots, they're going to cancel, and that's going to leave theta equals, if we sine inversed the left side, we've got to sine inverse the right side. This is also just a button on your calculator. You got to hit second function, and it's right above sine. So we would just punch this in our calculator. So you type in 200 divided by 400, hit equals to get that decimal, and then you'll do second function, hit the sine key for sine inverse, and a calculator should spit out theta equals 30 degrees. There's our missing angle. So if you're looking for an angle, you've got to use the inverse key. Got to use the inverse key. All right. This one, find length C and the height B of a skateboard ramp. So we built a ramp. The base of the ramp is 13 feet. The angle of elevation to the top is 18.4. And they just want us to find a couple of missing sides. So we could find the missing angle, but we really don't need it. We can do everything from the 18.4 degree angle's perspective. So let's see, we've got the adjacent side, and one of the sides we want is the opposite side, B. So if we want to find B, opposite, we have adjacent. What trig function deals with opposites and adjacents? That would be tan. The tan of 18.4 degrees is equal to opposite B over adjacent 13. To get B by itself, we're going to multiply both sides by 13. 13 times the tan of 18.4 degrees is equal to our B value. And I get out my calculator and it goes beep, beep, beep. And B is approximately 4.3245. 4.3245. In this case, they did give us units. It's that many feet. Okay, I'm going to switch to blue ink to go after a side C, the hypotenuse. So we're still at the 18.4 degree angle. We have adjacent. We want the hypotenuse. So that's going to be cos. The cos of our angle, 18.4 degrees, is equal to adjacent 13 feet over hypotenuse C. Now, since the C is in the denominator, we're going to multiply both sides by C and then divide by the cos. So over here is going to be 13 over the cos. That is a terrible S. The cos of 18.4 degrees. And we type that in our calculator, 13 divided by 18.4 cos, and hit equals. We get C is about 13.7004 feet. And that makes sense. The hypotenuse should be a little longer than the longest side. There we go. A huddle problem for you, a little practice. Actually, there's a couple of them here, 3 of them. So try this one, the angle between the paths. Don't forget you're going to use the inverse key for that angle. Here's one about a ramp. We're going to find the horizontal length and the hypotenuse. And we're going to find the height of a flagpole. So pause the video and try those. Fire it up and see if you got them right. Pause the video. Pause the video. Okay, here we are. Let me make this a little bit bigger so it's easier to see. Here is our angle theta. And what sides do we have? Well, we have the adjacent side, or touching it, and we also have the hypotenuse. So adjacents and hypotenuse. Let me shrink that back down. Adjacents and hypotenuse means we have to use cos. The cos of our angle theta is equal to the adjacent side 3 over to hypotenuse 6. And then to get this angle theta by itself, we're going to cos inverse this side to cancel. So the theta is left, and we're going to cos inverse 3/6. So in your calculator, punch 3 divided by 6 equals, you'll get a 0.5. You cos inverse that, and angle theta is 60 degrees. Okay, we've got a ramp. Very similar to the example. So here we are at the 11.5 degrees. We have the opposite. We want the adjacent, so that's going to be tan. The tan of 11.5 is equal to 3.5 over A. And we're going to switch the A and the tangent function. So A is equal to 3.5 divided by the tan of 11.5. And beep, beep, beep goes the calculator, and we get A is approximately 17.203 feet. Now on to the hypotenuse. We have the opposite. We want the hypotenuse, so that's going to be sine. Sine of our angle is equal to opposite 3.5 over hypotenuse C. So just like we did before, we're going to switch the place of those two. C is equal to 3.5 divided by the sine of 11.5. see is approximately 17.5555 feet. Okay, that's a nice ramp. And the last one, they didn't even give us a picture. I guess we'll have to draw one. Bring a little art class to math class. The angle of elevation to the top of a flagpole. So we need a flagpole. There's our flag. And we're down here. The angle of elevation to the top of the flagpole is 64.6 degrees. And we are standing at 19 feet from the flagpole. How tall is the flagpole? I'm just going to call it X because that's what we're looking for. So let's see, we're here at the angle. We want the opposite. We have the adjacent, so that forces us to tan. The tan of 64.6 is equal to the opposite, X, over the adjacent, 19. This is the easy variety. Multiply both sides by 19. 19 times the tan of 64.6 is equal to our X value. If we punch that in the calculator, X is approximately, well, we'll just round this off to 40, but it is 40.014 feet. But that's a pretty insignificant amount, so we got a 40-foot flagpole. Okay, is that the end of the video? Yeah, the homework, look for that on WebAssign, and the next time we're together, we'll do some odd problems. I will see